Okay, let's dive right in. You've probably seen it all over social media, maybe felt a bit of that panic even. About August 2nd, 2025.
Oh yeah, the big world goes dark thing.
Exactly. Claims of a total solar eclipse plunging the entire Earth into darkness. Some posts even said, last one for 100 years.
Wild stuff, and
Yeah.
completely off base, as we'll get into.
So today, we're really going to unpack the truth behind those rumors
Right. Our mission here is basically to cut through all that noise. We want to give you the real facts, the fascinating science behind these things.
and help you understand what's actually happening up there, why these events are so cool, and crucially, how to watch them safely when they do happen.
Yeah, definitely the safety part. And we're grounding this discussion in solid sources, looking at reports from places like the Economic Times and using guides like the September 2025 Partial Solar Eclipse Guide.
The solid sources. So let's start with that big debunking. The August 2025 claim.
Okay. So the story went viral, didn't it? Total solar eclipse, whole world dark for 6 minutes.
Plus that dramatic hook, last one for 100 years, really gets people clicking and worrying.
It absolutely does. But NASA, thankfully, stepped in pretty quickly and clearly.
What did they say exactly?
Their statement was unequivocal. No total solar eclipse is scheduled for that date, period.
Yeah.
And they specifically addressed the whole Earth in darkness idea, saying it's scientifically impossible, which, it is. The moon's shadow is never big enough for that.
Right, it only covers a narrow path. So where did the confusion come from? Just a mix-up.
It really seems like it. The most likely explanation is a simple year swap mixing up 2025 with 2027.
Ah, okay. So NASA clarifies, but it still makes you think about how fast misinformation spreads, right?
Yeah.
Even against clear science.
It's incredible, isn't it? I think it's often a mix of genuine fascination eclipses are awe-inspiring and maybe a lack of easily accessible authoritative info right when the rumor hits.
Yet nature abhors a vacuum,
Mm-hmm.
and so does social media, I guess. False narratives can fill that space quickly.
Especially dramatic ones like the world going dark. People are naturally curious, maybe a little apprehensive, and they latch on to the first explanation they see.
Which leads us perfectly to the actual event people should be marking on their calendars, the one scientists are already buzzing about.
Yes. August 2nd, 2027. That is a woman called the Eclipse of the Century.
Not a rumor this time.
Definitely not. This is the real deal, a total solar eclipse, and it's historic mainly because of its duration.
How long are we talking?
An amazing 6 minutes and 23 seconds of totality.
Wow, 6:23. How does that compare?
Well, most total eclipses, they usually last somewhere between, say, 2 and 4 minutes, so this is significantly longer. It's actually the longest land-visible total eclipse since back in 1991.
And the path sounds huge, too. Where's it going?
Oh, it's massive. It cuts across 11 different countries. The path itself is something like 9,462 miles long and about 160 miles wide.
11 countries. Which ones?
Okay, let's see. It starts over Spain, touches Gibraltar, then goes across Morocco, Algeria, Tunisia, Libya, Egypt.
So, a lot of North Africa.
Exactly. Then Sudan, Saudi Arabia, Yemen, and finally Somalia. It's quite the journey.
So, crucial point. If you're not in that relatively narrow 160-mile band, you won't see the total eclipse.
That's right. You might see a partial eclipse where the sun looks like a crescent, or depending on how far away you are, you might not see anything unusual at all.
Okay, so why is this one, the 2027 eclipse, so incredibly long? You mentioned the duration.
Right. It's down to a really interesting combination of 3 astronomical factors lining up just right.
What are they?
Okay, first, Earth will be near what we call aphelion.
Aphelion, that's its farthest point from the sun in its orbit.
Precisely. So when Earth is farther away, the sun appears just a tiny bit smaller in our sky.
Okay, factor 1, smaller looking sun. What's 2?
Factor 2 involves the moon. At the time of the eclipse, the moon will be near perigee.
Which is the opposite, right? Closest point to Earth.
Exactly. So a closer moon appears slightly larger in our sky.
Got it. So, smaller sun, bigger moon. That makes it easier for the moon to cover the sun completely and for longer.
You've got it. That combination is key. But there's a third piece.
Okay, what else?
It's about where the eclipse path falls on Earth. This path lies quite close to the equator.
And why does that matter?
Well, near the equator, the moon's shadow actually moves across the Earth's surface more slowly than it does at higher latitudes. Think about the speed of Earth's rotation being faster at the equator.
Ah, I see. So the shadow itself lingers longer at any given spot along that equatorial path.
That's the idea. Slower shadow means longer duration of totality for people watching from the ground. It's this trifecta, aphelion, perigee, and the equatorial path that pushes the duration over 6 minutes. Really quite special.
It sounds incredible. Can you paint a picture of what someone in that path actually experiences during totality?
Oh, it's something else. It starts subtly, the moon takes a bite out of the sun, but as totality approaches, the change accelerates.
Daylight just fades.
It fades rapidly into this eerie, deep twilight. It's not like night, it's different. Quite sudden darkness, actually. You might feel the temperature drop noticeably.
Wow. And animals react too, I've heard.
Often, yeah. Birds might go silent or head to roost. Nocturnal animals might stir. It's like a false dusk hits very, very quickly.
And then the main event, the corona.
Yes, that's the breathtaking part. With the sun's blinding disk completely blocked, its outer atmosphere, the corona, suddenly becomes visible. It looks like this ethereal, wispy halo glowing around the black circle of the moon.
That's the image everyone hopes to see.
It is. And you might even spot bright stars or planets like Venus or Jupiter pop out in the middle of the day.
Amazing. What about those other effects, the diamond ring and Bailey's beads?
Right, those are transition markers. Just before totality begins, and just as it ends, the last few rays of sunlight can peek through valleys on the moon's edge. Bailey's beads look like a string of bright points. And the diamond ring is when just one final brilliant point of light shines through, looking like, a diamond on a ring around the moon. They signal totality is starting or ending. Truly unforgettable moments.
It sounds almost otherworldly. You can see why people travel the globe for those few minutes.
Absolutely. Some people become dedicated eclipse chasers after seeing just one.
Okay, so the big one is 2027. But let's circle back to 2025 for a sec. While there's no total eclipse on August 2nd, there is an actual eclipse happening later that year, right?
Correct. Important clarification. There is a partial solar eclipse scheduled for September 21st, 2025.
And partial means.
It means the moon only covers, part of the sun. You won't get that complete darkness or see the corona. Instead, the sun will look like a crescent, like someone took a bite out of it. Still cool, but a different experience.
Where will people be able to see this partial eclipse in September 2025?
The visibility zone for this one includes parts of Africa, Southern Asia, and Europe, but it's particularly good for viewers in New Zealand.
Oh, really? How much coverage there?
Down in Stewart Island, they could see up to about 80% of the sun covered. In Auckland, it'll be more like 60%, so pretty significant partial coverage.
Anywhere else?
Yeah. Also visible from Fiji, parts of eastern Australia, various Pacific islands, and even Antarctica. The maximum eclipse magnitude is about 0.855, meaning roughly 85.5% of the sun's diameter is obscured at the peak point.
But important note, not visible from the Americas or most of the Northern Hemisphere.
Correct. You'll need to be in the right part of the world for that one.
And there are others coming up too, even before the big 2027 event.
Yes, definitely. We shouldn't forget those. There's another partial eclipse even sooner, March 29th, 2025.
Where's that one visible?
That one's visible from parts of the northeastern U.S., Canada, Greenland, Europe, northwest Africa, and into Russia.
Okay. And then in 2026.
February 17th, 2026 brings an annular eclipse.
Annular, that's the Ring of Fire, right?
Exactly. That's when the moon is a bit farther away, so it appears slightly smaller than the sun. It can't quite cover the whole disk, leaving a bright ring or annulus of sunlight visible around the moon.
Where's that one visible from?
Primarily Antarctica and surrounding southern oceans, so maybe not the easiest one for most people to see.
Probably not.
Yeah.
What else in 2026?
Then August 12th, 2026, there's actually another total solar eclipse.
Oh, before the 2027 one.
Yes, though maybe not quite as long or widely hyped. This one's path crosses over Greenland, Iceland, parts of Spain, Russia, and a tiny bit of Portugal.
So quite a few opportunities to see different types of eclipses in the coming years. We've got partial, total, annular. Are there any other kinds?
Well, there's one more much rarer type called a hybrid eclipse.
Hybrid. What's that?
It's basically an eclipse that starts as annular, becomes total along the middle part of its path, and then reverts back to annular towards the end. It happens due to the curvature of the Earth and the precise moon distance. Very unusual.
Fascinating. So, okay, these events are clearly amazing spectacles. But why do they matter beyond that? Why are scientists so interested?
That's a great question. They're incredibly important scientifically. During a total eclipse, that brief window of darkness allows researchers to study parts of the sun that are normally completely overwhelmed by its brightness.
Like the corona you mentioned.
Exactly. The corona, the sun's magnetic fields close to its surface, solar prominences, these are hard to study otherwise. NASA points out that eclipses let them study the corona, test theories like Einstein's theory of relativity,
How do they test Einstein's theory?
by observing starlight bending around the sun's gravity, which is only possible when the sun's glare is blocked. Eclipses also help improve our understanding of space weather, which can affect satellites and power grids here on Earth.
So for scientists, it's a critical, if short, period for data collection.
Absolutely vital. But, I think there's also a human element. For millennia, eclipses were terrifying, seen as omens. Now, we understand them, but they still connect us to the cosmos in a very direct, powerful way.
A shared experience.
Yeah, watching an eclipse, especially a total one, alongside thousands of other people, all looking up in awe, it's a profound, unifying moment. Kind of reminds us we're all on this small planet together watching these grand celestial mechanics play out.
That's a lovely way to put it. Now, perhaps the most critical piece of advice for anyone planning to watch any solar eclipse, partial or total.
Eye safety. Yes, cannot stress this enough.
Rule number 1.
Never, ever look directly at the sun without proper certified eye protection. Even a sliver of the sun can cause serious, permanent eye damage.
And regular sunglasses won't cut it.
Not even close. You need special-purpose solar viewing glasses or handheld viewers. Make sure they meet the ISO 123-125-200 and National Safety Standard. Look for that number printed on them.
What about things like smoked glass or old film negatives? I've heard people mention those.
Absolutely not. Very dangerous, unsafe filters. Don't use them. Don't use welder's glass unless you know it's the correct shade 14 or higher. Stick to the certified eclipse glasses or viewers from reputable sources.
Is there any time it's safe to look without filters?
Only during the brief period of totality in a total solar eclipse, and only if you are located within the path of totality. The moment the first Bailey's bead or diamond ring appears, signaling the end of totality, you must look away or put your filters back on immediately.
Okay, crucial distinction. Totality only, and only if you're in the right spot.
Exactly. For partial phases, or if you're viewing an annular eclipse, you need protection the entire time.
Are there other safe ways to view if you don't have glasses?
Yes, indirect methods work well. You can make a simple pinhole projector using 2 pieces of card, or even just project the sun's image through the gaps in tree leaves onto the ground. Or, of course, watch online live streams from NASA or observatories.
Good alternative.
Hmm.
And planning ahead is probably P2, right? These events draw crowds.
Definitely. Check the exact timing for your location using reliable sources like NASA's website. Find a spot with a clear view of the sun. And yeah, anticipate traffic and crowds, especially for total eclipses. Give yourself plenty of time.
All right, so let's bring it all together. The big takeaway. That August 2nd, 2025 rumor. False. Debunked by NASA. No total eclipse then.
Right. The real headline event to look forward to is the spectacular total solar eclipse on August 2nd, 2027. That's the eclipse of the century, with over 6 minutes of totality.
And its path crosses those 11 countries, mainly in North Africa and the Middle East.
Correct. But remember, there are other legitimate eclipses coming up too, like the partial one on September 21st, 2025, visible in places like New Zealand, and others in March 2025 and August 2026.
So while these cosmic events are rare and special, they happen regularly enough that there's no need for panic. Now you have the accurate info.
Exactly. Be informed, be prepared, and if you get the chance to see one, be safe.
Which leaves us with a final thought, perhaps. Given the incredible, almost clockwork precision needed for these eclipses to happen, the perfect alignment of sun, moon, and earth, what else might we discover, or maybe just appreciate, about our little place in the vast universe if we just take the time to look up?
Safely, of course.
Safely, always, something to ponder.